I'm Bruce Bugby, president of Apogee Instruments, and I wanted to record a video to discuss terminology for measuring photosynthetic radiation. This is real confusing to people, and the terms have evolved over the last 20 or 30 years. So since Apogee is in the business of helping people make excellent measurements of this, we want to make sure the terminology is also clear. So this is going to be a short video, but I want to take you back to the 1960s when we used to measure radiation only with the pyranometer. Now this is going way back. And let me put this curve over here. Here's wavelength, and this is all shortwave radiation, and this curve looks something like this. Fill in that spot right there. This is 2,800 nanometers out here, and this is about 280 nanometers right here. This is all shortwave radiation from the sun. Only this part right here causes photosynthesis. This is this part right in here. And you have to remember what the instruments were like in the 1960s. We measured all of this and used it to predict plant growth. But we also knew that this part over here is near infrared. I'm going to put NIR. And our instruments that included this, it was not a good prediction of plant growth. So with this is PAR right here, photosynthetically active radiation. This was the first term that we evolved to say we're only counting PAR as the radiation. So this is in the 1960s and even into the 1970s. This was everywhere in the literature. PAR, that's what we're measuring. But what were the units people used? The units we use for all of this are watts per meter squared. Total energy. This is what drives transpiration, but it's not what drives photosynthesis. This part drives photosynthesis. So we developed this term PAR, but we kept the units the same. We said PAR was watts per meter squared, and it was an improvement over the whole thing. Time passes, Keith McCree comes out in the early 1970s and says, no, it's not the energy, it's the number of photons that cause photosynthesis. We need to start counting photons, not energy. So we evolve from the term PAR to measure, this stands for photosynthetically active radiation, to a term called PPF. Now this is an easy term to remember, photosynthetically active radiation. This stands for photosynthetic photon flux. And it's a more rigorous term. And this, in the 1960s and 70s, this often meant watts per meter squared, which was not very accurate. This specifically meant micromoles of photons per meter squared per second. The story would end here. This is a more rigorous term for moles of photons than the old term PAR, but language evolves. People kept using PAR to mean micromoles per meter squared per second. So it got confusing. These terms were used interchangeably, and they are used interchangeably to this day, but we try to use a more rigorous term for just the photon's flux. Now, the P stands for photosynthetic. That means 400 to 700. I'll write this down here. If you're going to get a degree in plant science, you got to measure 400. You got to remember 400 to 700. Both of these are photosynthetic. This is a photon flux. Now, what about PPFD? Is that different? It depends on what part of the literature you read. These two terms have been used interchangeably for 50 years in the literature, and they are still used interchangeably today. And even during my career as a researcher, we have used these interchangeably. But we are evolving now to different definitions. How can this, the D stands for density. If you look up on the internet the word flux, now let me see if we can do this. We go to a next screen. I'll come back to that screen. Flux. What's the definition of a flux? If you type it in, do a Google search, you come to the Wikipedia page, and it says flux equals an amount per area per time. This is micromoles per meter squared per second. If you look up flux density, this is also micromoles per meter squared per second, but it turns out physicists have trouble with the word flux. Many people define flux as just an amount, I'm going to abbreviate amount, per time. And a flux means an amount per time. Let me put something like about. These terms are used interchangeably. If flux means an amount per time, then we reserve flux density for amount per area per time. AMT, amount, area, time. So in my publications, starting about 3 years ago, we started to use PPFD instead of PPF. When we use PPF, the argument was that the D is redundant, and that's the worst case in writing, to put redundant things in your writing. The PPF was adequate. But some people were using PPFD separately, and I did a big literature survey, and it turns out people in plant ecology were using PPFD. People in horticulture and agronomy were mostly using PPF. So different disciplines use this acronym slightly differently. You would think that's horribly confusing, but both of them always showed the units after this. And as long as you show the units, you know what people are talking about. About 3 years ago, I started using PPFD, and what that means is now we can use PPF to mean just, I'm going to see if I can put it right here, micromoles per second. No area in this. This one for sure has the area. This is area times time. So, historically, these have been used interchangeably, but we're trying to shift the terminology in the literature. This is papers that I review as a scientist in both my own writing, to use PPFD. The argument now is it's better to be redundant than it is to risk being unclear. because D always means area. So now we're starting to evolve a definition where this just means per second, no area in it. That's the difference between these terms. So if we go back to this, PAR is still used by lots of people in just common speech to refer to a photon flux density, but technically we try and reserve the term PAR for a generic term. That could mean energy flux, it could mean photon flux. PPFD we try and reserve for an amount per area per time. And then now we're starting to use PPF, no meters squared, just micromoles per second. So in our literature at Apogee, you will see when we talk about a flux, we will say PPFD. Maybe it's redundant to some people, but it's absolutely clear to have all four of those letters in there. An example of this would be, let's take a light. Let me see if we can go one more screen. If we're testing some light, and this has photons coming out of it, if we want to know the total number of photons out of this light, we would do a PPF in micromoles per second. There's no area, it's a total. It doesn't matter if the photon's way over here or in the middle, it's a total number of photons. This is important when we're testing the efficacy of a light. But if we want to know the intensity at any given place, now we have to put the meters squared in here and say this is the intensity, because if you don't know the area, you don't know the amount of light for plant growth. And now when we put that area in there, it becomes PPFD. And the D stands for density, and that stands for meters squared. A way to think about this, let's try one more screen. If we have a box right here, oh man, that's a bad box. Let's see if we can erase that. There. Here's a three-dimensional box, like a giant cookie sheet. Here's our photons coming in like raindrops into this box, falling into it. If we want to know the number of photons we get, we want to know amount of raindrops per meter squared of box per unit time. We've defined all three things, and now we know the intensity of the rainfall. If we just said the photons, there was 10,000 photons per second, it's not helpful because we need to know the intensity. We always need to have the meters squared in there. So when you read literature, look for the units. If the units are correct, and they should be, micromoles per meter squared per second, you will see the older literature used to call that PPF, and that's fine as long as they've defined it. But we're trying to change this to PPFD, and we have begun using that at Apogee. We've begun using it in science, and that's the evolution of language from one term that we thought was adequate to a new term that has more letters in it to be more precise. Thanks for listening. Look forward to talking to you again soon. And one more thing. There's a new term that we have started to use in our research. Remember that this P stands for photosynthetic, and that means 400 to 700. But we now know these photons out here, let's see if we can put this in red. There's photons right here that we call far red radiation that actually cause some photosynthesis. So we're calling into question this whole definition of 400 to 700, and even more than that, down here, let's see if we can do this in blue. This is U ultraviolet, and these have some effect both on photosynthesis and on plant growth. But if we say the PPFD, that automatically excludes these, because the P means photosynthetic, and for 30, 40, 50 years we've said that's 400 to 700. So now we're looking into the future evolution of language and terminology more than language. So we have a new term, the PFD. Just when you thought you had it right, here's a new term. This P stands for photons, not photosynthetic. The photon flux density. And when we use this term, we are not constrained by 400 to 700. So when we do research, the PFD, when we're using it, can mean 300 to 800. So here's a new emerging term that counts these photons at the edges. Doesn't have the extra P in it, which means photosynthetic. It's just the total number of photons. Watch for it in the literature. It's going to be a useful term. Thanks.